Now, in this question, we're told that we have a plate cam of 35 mm, minimum radius, camshaft diameter 30 mm, turning uniformly clockwise. So the follower is a roller type and has a 20 and is 20 mm in diameter. So from 0 to 180, it has a rise of 64 mm with simple harmonic motion. From 180 to 240, it's a dual period, while 240 to 360 is a fall of 64 mm with uniform velocity. So we're expected to draw the cam profile using intervals of 30 degrees and then show the construction clearly. Okay, so first thing, we draw the horizontal line, and then we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So each is 30 degrees. So now we draw a perpendicular perpendicular line from this point, from point 0. Okay, that's away from this point. You draw this. So this place, we are told that it had a lift of 64 mm. So that means from here we're going to have to this place we're having 64. So the first motion is simple harmonic motion. So from here you take your radius of 32 mm and then you divide the semicircle into 6 equal parts. So you can draw a perpendicular line here so as to get another point of intersection here. Then from here you get this cut here, and then you get the second cut. So with that, you'll be divided the semicircle into 6 equal parts. You then draw a horizontal line from this point, the first one using thin continuous line. The second one, the third one is already there. The fourth, the fifth, and then the sixth. So now this is 0. This 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So from 0 to 180, so this is going to be 180 degree here. From 0 to 180, we have simple harmonic motion. So it means we're going to draw vertical lines from this point. So that was 0 is already there. We draw vertical line from point 1. So the same thing with 2 up to 6. You then look at the points of intersection. This is 0, this is 1, this is 2, 3, 4, 5, and then 6. So you draw a curve and use French curve, or you carefully use your hand to draw the curve. So now we're told from 180 degree to 240 degree we have a dual period. So here we have 240 here. So you can draw a vertical line So you draw the vertical line through 240, and then this is your dual period here. So the next, we have a fall with uniform velocity. So now this is the last point, which is where we have 360 degree here. So from 12 to this point, since it is uniform velocity, that makes it a whole lot easier. And now this is the displacement diagram. So now to draw the cam profile, we're given the main radius as 30 mm, but this time around it's a roller follower, and the follower has a diameter of 20 mm. So that means the radius is going to be 10 mm. So now you're going to add the radius of the roller, which is 10 mm, you add it to minimum radius of 30. I mean the radius of the roller here is 10, so it means you are going to add 10 to 35, which is the minimum radius of the camshaft, and that means 35 plus 10, that was going to be 45. So this is 45 mm. 45 mm. The next is to divide the circle into 12 equal parts. After dividing the circle into 12 equal parts with the aid of your ruler and then 30, 60, 90 degrees set square, now you have here is 1, 1 prime, 2, 2 prime, 3 prime, 4 prime, 5 prime, 6 prime, 7 prime, 8 prime, then 9 prime, 10 prime, 11 prime, and then 12 prime. So now that the direction of the rotation is clockwise, it means counting is going to be anti-clockwise. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, back to 12. So now you take the distance 1, 1 prime, 1, 1 prime, and then here also have 1, 1 prime here. The next is you take the distance 2, 2 prime, 2, 2 prime, and then you cut it arc here. The next one is 3, 3 prime. So the same thing you do for 4 prime, 5 prime, until you get to 12 prime. Now the radius of the roller is 10. So starting from this point, you take, then you can draw a circle, or you can just draw an arc to cut this line. The same thing here, you come to this point, you draw an arc to cut the line. The same thing here, you come here, draw an arc to cut this line. You can make it a whole circle. You draw an arc here to cut this line here. You draw an arc to cut the line here, the same thing. So that's how you draw it for all the other lines, the point of intersection. So as you can see, the same thing for line 10, and then the same thing for this point, and then back to 0. So now the idea is this point of intersections here, 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 like this, like this. So tangential to all these points of intersection, that's where your curve is going to pass. So now this is a cam profile. So don't forget, from the question we're told the direction of rotation is clockwise, so you indicate that. And then since it's a roller follower, you can also draw this to indicate it's a roller follower. Don't forget, this is the initial circle we drew here. So this is supposed to be your initial circle of the radius of 10 mm. So now this is your displacement diagram, and then this is the cam profile. So this is the camshaft. This is the camshaft diameter. So this has a diameter of 30 mm, while this has a diameter of 35 plus 10, making 45 mm.